Hello everyone, it's me Arvind. Catch you guys on another Math Tutor Edu's lecture video. Okay, in this lecture video we are going to discuss the first derivative. Okay, within the first derivative we're going to go through the techniques of differentiation part 2. Okay, this video will be the part 2 video of the technique of differentiation, guys. By the way, if you haven't watched the part 1 video, okay, I've included in the link above, so please go and watch that video first before coming and have a look at this video, because for better understanding, some of the concept of the part 1 will be included in this part 2 video. So for your better understanding, so please watch that video first and then you come and watch this part 2 video. Okay, so in this technique of differentiation part 2 video, we are going to discuss another two more new concept, which is the products rule and the quotient rule. Okay, so we will take a look at the products rule first now. Okay, so from here, products rule. Okay, so let me underline this. Okay, when you heard this word product, okay, it means a multiply. Okay, that means your differentiation must be related to a multiplication. Okay, so similar to that meaning, so given that your y is equals to u v, okay, so u is a one term and v is another term. Okay, so this is a product rule, guys. Okay, so when you come across with these two terms which involving the multiplication, so you need to use this products rule. Okay, so how are you going to differentiate this? So I'm going to show you now. Okay, to differentiate this, so from here your dy over dx, okay, will be equals to, so we start with the term u first. Okay, u, okay, you times with the differentiation of v. Okay, in this case is dv over dx. Okay, and then you plus with v, and then you multiply with the differentiation of u instead. So v du over dx. Okay, so let me box this. So this is actually your products rule, guys. Okay, let me box this. Okay, make sure you remember this formula, because this formula is crucial. Okay, so beside writing in this form, you can also write this formula in this way, where y prime is equals to u v prime plus v u prime. Okay, if you think that this takes a big space, you can just write in this simple way also can. It is acceptable, guys. Okay, either one way. If you wish to write in the first way also can, or if you want to write this second way also can. Okay, so let me just box this as well. Okay, now you can ask me, sir, you have already shown the formula, so how about the examples? Wait, I'm going to show you the examples. Okay, now, so I do have some examples to you, which I'm going to show you how we're going to apply the products rule. Okay, so let me show you the example now. Okay, so example 1. Okay, given that your y is equals to 4x plus 8, okay, and then you times with x square plus 1. Okay, so this is one of the problem that involves us to use the products rule method. Okay, so how are we going to apply the products rule here? Okay, so let me teach you, okay, one by one. So step number 1, you need to identify which will be the u term and the v term respectively. Okay, so for our convenience, we take the first term as the u and the second term as v. Okay, the order actually doesn't matter. You can even put v first and then u at the second also can, but for the convenience, okay, I recommend you to write the u in the first one, okay, and followed by v in the second one. Okay, so this is your step number 1, where identify the term u and v. Okay, so once you already identify, okay, the y is equals to uv, okay, we follow exactly the products rule formula. Okay, the next step is, so we're going to find the derivative of u and v. So we're going to differentiate u and v respectively. Okay, so from here, so given that du over dx, so you differentiate u with respect to x. So in this case, which term is u? For x plus 8. So when you differentiate u with respect to x, so 4x plus 8, so you differentiate this, you only have 4. Okay. Okay, you're done with u. Okay, now we go for v. So now you differentiate v with respect to x. So dv over dx, so take a look at the v term here. So you have x squared plus 1. Okay, so you differentiate x squared plus 1, so you get 2x. Okay, the 2 you move in front. Okay, and the power 2 you minus with 1. So that's how you get 2x over here. Okay, so this is technically your step 2. So once you identify the du over dx and dv over dx, so the next step, you just straight away apply this formula. Okay, so to find your dy over dx, okay, you start with the term u. Okay, the term u in this case is 4x plus 8. Okay, so you write here 4x plus 8. Okay, and then times with dv over dx, differentiation of v. Okay, remember u times with the differentiation of v. So you cross multiply here. Okay, u times the differentiation of v. Okay, so in this case, your differentiation of v is 2x. So 4x plus 8 you times with 2x over here. Okay, so understand or not? So you times this. Okay, and then plus with, okay, v. Okay, in this case, your v is x squared plus 1. Okay, and then you times the differentiation of u. Okay, in this case, du over dx is 4. So x squared plus 1 you times with 4. Okay, you cross multiply. Okay, so x squared plus 1 you times with 4. Okay, so from here, so let us perform the expansion. So from here, dy over dx will be equals to, so from here 4x times with 2x, so from here you get is 8x squared. So 8 times with 2x you get is 16x. Okay, plus with, okay, this 4 you times in, so from here you get is 4x squared plus 4. Okay, so we are almost near to the final answer. So from here you get your dy over dx is equals to, so 8x squared plus with 4x squared, so from here you get is 12x squared. Okay, then you plus with 16x, okay, and plus with 4. Okay, so this is your answer for the example 1, where you get your dy over dx is equals to 12x squared plus 16x plus 4. Okay, so let me underline the solution for the example 1. Okay, if you don't understand, okay, don't worry, take it slow and steady. I will show you a couple more examples and I'm sure you will able to understand. Okay. Okay, by the way guys, this long step is for your understanding. Okay, once you are able to master the products rule, okay, these steps guys, okay, where I'm showing you what is du over dx and the dv over dx, you can just straight away omit them and straight away jump to the working. Okay, this extra step is for your understanding purpose guys. Okay, for me to teach you. Okay, so we have already done with the example 1. So let's proceed to the example 2 now. Okay, so in the example 2, so given that your y is equals to 3x squared plus 2, okay, and then times with 2x squared minus 5x plus 1, okay, close bracket. Okay, so from here you have two terms which multiplying together. So the question asks you to find dy over dx. So how are we going to find this dy over dx? Okay, we're going to apply using the products rule. Okay, remember guys, when you want to apply using the products rule, first step, identify the u and v. Okay, this will be your u, and this term will be your v. Okay, so from here the next step is we perform the differentiation of u and v respectively. So let us start with the u first. So from here, du over dx. So when you differentiate u with respect to x, so from here you get, okay, 2 times with 3 you get is 6. Okay, the power 2 you minus with 1, so you only left with 6x. Okay, next we take a look at the v. So we differentiate v with respect to x. Okay, so from here you only left with, okay, so from here you get 4x minus 5. Okay, so from here, for the next step, in order to find the dy over dx, okay, in this case, let me just straight away write the y prime, guys. Okay, y prime is equals to u v prime plus v u prime. Okay, that means, so you times with the differentiation of v, and then plus with v times the differentiation of u. Okay, don't worry, I'm going to show you the step by step working now, so pay attention. Okay, so you're going to apply this one. So from here, or you can write dy over dx also can. Okay, so just let me box this. So from here, dy over dx is equals to, okay, 3x square plus 2. So this is your u term. So 3x square plus 2, okay, times with 4x minus 5. So this is your differentiation of v. Okay, like I mentioned here, u v prime, okay, plus with v. So which one is the v term? 2x square minus 5x plus 1. Okay, so you just write over here 2x square minus 5x plus 1. Okay, and then you times the differentiation of u, okay, which in this case is 6x. Okay, u v prime plus v u prime. Okay, in this case we already fulfilled that. Okay, u times with the differentiation of v plus v times with differentiation of u. Okay, so let us perform the working together. So dy over dx is equals to, okay, so let us perform the expansion. Okay, so from here 3x square times with 4x, so from here get is 12x cubed. Okay, 3x square times with negative 5, so from here get is negative 15 x square. So 2 times with 4x, so from here get is 8x. 2 times with negative 5, so from here get is negative 10. Okay, and then you plus with, okay, this expansion. So 6x times with 2x square, so from here get is 12x cubed. 6x times with negative 5x, so from here get is negative 30x square. 6x times with 1, so from here get is 6x. Okay, so far so good. So from here let us proceed to the next step. So from here your dy over dx, okay, start to solve the highest power first. 12x square plus with 12x, so sorry guys, it's 12x cubed. 12x cubed plus with 12x cubed, so from here get is 24x cubed. Okay, proceed to the power of 2, negative 15x square plus with negative 30x square, so from here get is negative 45x square. Okay, 8x plus with 6x you get is 14x. Okay, and you left with minus 10. So from here your dy over dx will be equals to 24x cubed minus 45x square plus 14x minus 10. Okay, so let me underline the solution for example 2. Okay, so let us proceed to one more example before we proceed to the quotient rule now. Okay, so from here, example 3. Okay, so given that y is equals to, okay, in a bracket 5x minus 9x cubed, okay, and then you times with 8 plus x squared. Okay, so take your time, pause this video and try to think on how to solve this using the products rule method. Okay, so in a count of 5, 4, 3, 2, 1. Okay, so now we're going to show you on how to solve this question, so using the products rule. Okay, so to find the dy dx, so what you're going to do is, so this first term you're going to label as u, and this second term you're going to label as v. Step number 1, clear. Next, proceed to the step number 2, differentiate u and v respectively. So from here, du over dx, so from here, okay, you get is 5 minus, okay, 3 times with negative 9, so you get is negative 27. So the power 3 you minus with 1, so from here you get is negative 27 x squared. So this is your du over dx. Let's proceed to the dv over dx. Okay, so from here, dv over dx, so you differentiate v with respect to x, so from here you get is 2x. Okay, so the next step is you just cross multiply and plus them together. Okay, so from here, dy over dx will be equals to, okay, u in this case is 5x minus 9x cubed times the differentiation of v, in this case is 2x, plus with v, which in this case is 8 plus x squared, 8 plus x squared, times the differentiation of u, which in this case is 5 minus 27 x squared. Okay, you know what, I just move it over here. Okay, so let us perform the expansion. So from here, 5x times with 2x, so from here you get is 10x squared. So negative 9x cubed times with 2x, so from here you get is negative 18 x to the power of 4. Okay, plus with, okay, so let us solve this one by one. So 8 times with 5 is 40. So 8 times with negative 27. So you get here is, so please wait for a moment. Let me calculate this. So negative 27 times with 8. So you get is 216. X squared. Okay, so 8 times with negative 27 x squared, you get is negative 216 x squared. Okay, and then x squared times with 5. Okay, so you get is 5x squared. So x squared times with negative 27 x squared, so from here you get is negative 27 x to the power of 4. Okay, so from here let us solve the expansion one by one. So from here dy over dx, Okay, so from here let us start with the highest power. So negative 18x to the power 4 minus 27x to the power 4. So from here get is negative 45x to the power 4. So this one is clear already. Okay, and next, so negative 216x square, okay, plus with 15. So negative 216x square plus with 15. So from here get is negative 201x square. Okay, 216, negative 216 plus with 5 is negative 211. So negative 211 you plus with 10. So from here get is negative 201. Okay, and then plus with 40. So this is your final answer for example 3. So let me underline this. Okay, so I hope you understand the concept of the products rule, guys. I know the working is a bit tedious, but you need to do the expansion one by one. Okay, just need to be careful on the expansion side. Okay, otherwise the working is quite straightforward. Okay, the step 1, step 2, and then the step 3, and then once you finish all the 3 steps, it leads you to the final answer. Okay, so from here let me erase this and we will continue to the quotient rule. Okay, so here change this to quotient rule. Okay, so from here the quotient rule, so the concept is almost similar to the products rule. Okay, the only difference is products rule is the multiplication, quotient rule is the division. Okay, so from here given that your y is equals to u over v, okay, when the question asks you to find the differentiation dy dx, okay, based on this type of term, okay, the following formula will be, so from here dy over dx will be equals to v times the differentiation of u, okay, in this case v times du over dx minus u times with dv over dx, okay, and then you divide with v square. Okay, so technically v times the differentiation of u minus u times the differentiation of v, and then you divide with v square. Okay, so let me box this formula. Or you can write in this term where y prime is equals to v u prime minus u v prime divided with v square. Okay, this way is much easier for us to remember. Okay, or if you think that the first one is easier, it's up to you guys. So let me box this as well. Okay, so I already show you the formula, so let's quickly jump into the example. So from here let me show you the example 1. So given that y is equals to 4x square plus with 10, and then you divide with 3x minus 1. Okay, let me underline the fraction. Okay, so from here, let's say the question asks you to find the dy dx of this term. So how are you going to find this? Okay, so when you come across with this term, okay, that means that you need to use the quotient rule. Okay, when you're involving the fraction line, okay, also that, so you need to use the quotient rule. Okay, like I said, similar to the products rule, so you need to identify which one is the u and v. So in this case, your numerator will be u, okay, and the denominator will be the v. Okay, like I said, similar concept, but they're not the same, guys. Okay, u, v. Okay, your numerator will be u, your denominator will be the v. Step number 1. Let us proceed to the step number 2. Okay, so from here, let us apply this formula. But before that, okay, let me differentiate u and v respectively. Okay, so from here, du over dx, so you differentiate u with respect to x. So from here you get is 8x. Okay, so we're done with u. Let us go with the v. So from here, dv over dx is equals to 3. Okay, you differentiate v with respect to x, so 3x minus 1. So if you differentiate this, you get is 3. Okay, step number 2 clear. Step number 3, apply the following formulas. Okay, so from here, dy over dx, so from here it is equals to v, in this case is 3x minus 1, times with the differentiation of u or u prime, in this case is 8x. Okay, be careful guys. 8x minus u, okay, 4x square plus 10 times the differentiation of v, which in this case is 3. Okay, and you divide with v square. In this case is 3x minus 1 square. Okay, so let me remind you in the earlier step. Okay, this 3x minus 1 square, you no need to expand guys, you can just leave it in this way. Okay, even when you have your final answer also, you just leave your answer in this way, by 3x minus 1 square. Or in future, if you have cube, power of 4, power of 5, you just leave it in that way. Okay, so let us perform the expansion at the numerator. So from here, dy over dx, okay, is equals to, so let us perform the expansion. So from here, so you get 24 x square, okay, minus 8x, okay, minus, so from here you get is 12x square plus 30, and then you divide with 3x minus 1 square. Okay, so from here you solve this, you should get your differentiation. So 24x square minus 12x square, so from here get is 12x square, negative 8x minus with, okay, there's no x term, so you can just leave your answer in negative 8x, so minus 30, and then you divide with 3x minus 1 square. So this is your final answer guys. Okay, so step number 1, identify the u and v. Step number 2, you differentiate them, the u and v respectively. Step number 3, you apply the formula and you get the answer over here. Okay, let me underline the solution. Okay, so from here, let us proceed to the second example. Okay, more example means more exposure to you guys as a student, so it's better, right, after all. So example 2. So given that y is equals to 2x plus 1, okay, and then divide with 3x minus 2. Okay, let's say the question asks you to find the dy over dx. So how are we going to find? Okay, so pause this video, okay, take a moment and figure out how to find this. If you could find it, okay, well done. But if you couldn't find it, okay, let us solve this question together. Okay, so from here, step number 1, okay, this will be the u, okay, and the denominator will be the v, okay, and then let us proceed to the differentiation of u and v respectively. So du over dx in this case will be 2 and dv over dx will be 3. Step number 2 clear. Let us proceed to the step number 3. Okay, by the way, this step number 2 is optional, guys. Okay, like I've mentioned for the products rule as well, once you are familiar with the formula, you can omit this step number 2. You can straight away jump to the step number 3. Okay, but for that you need to have more practice. Okay, so now we're done with the step number 2. Let us proceed for the step number 3. So dy over dx is equals to, so v 3x minus 2 times with u prime. Okay, u prime is the differentiation of u with respect to x, so in this case is 2 minus u 2x plus 1 times the differentiation of v. So where is the differentiation of v? Is this. So dv over dx is equals to 3. So 2x plus 1 times with 3. And then we divide with 3x minus 2 squared. Okay, so let us solve this one by one. So dy over dx, so is equals to, so from here you get 6x minus 4, okay, and then minus with 6x plus 3. Okay, let me just put it in bracket first. Okay, and then you divide with 3x minus 2 squared. Okay, so from here let us solve the numerator. Okay, so the 6x and 6x you can cancel them out. Okay, 6x minus 6x get is 0. So from here negative 4 minus with 3, so from here you get is negative 7. So from here your dy over dx will be equals to negative 7 divided with 3x minus 2 square. Okay, so that is your example, that is your final answer for example number 2. Okay, so let me underline the solution. Okay, so let us move on to the one last example before we end our video for today. So example 3. Okay, so from here y is equals to, okay, let's say they give you 12, okay, no need 12 guys, okay, just give you a simple one, 2x squared plus with 4x plus with 8, okay, and then divide with 5x plus 2. Okay, so let us solve this together. Okay, step number 1, identify which one is the u and v. Okay, based on the quotient rule formula, okay, when you take a look at over here, y is equals to u over v. So the numerator is u and the denominator is v. Okay, so in this case, so this will be a u term and over here will be the v. Okay, so let us perform the differentiation of u and v respectively. So from here du over dx will be equals to, okay, so from here 4x plus with 4. Okay, let us proceed to the differentiation of v respect to x. So from here dv over dx, so you get is 5. Okay, so step 1 is clear, step 2 is clear. Let us proceed to the solving using the quotient rule. So from here, given that your y prime is equals to v u prime minus u v prime divided with v square. Okay, Let me just box this. So from here, your dy over dx is equals to, okay, v 5x plus 2 times the differentiation of u, which in this case is 4x plus 4. So this is your differentiation of u, 4x plus 4, minus u, in this case is 2x squared plus 4x plus 8, 2x squared plus 4x plus 8, okay, times the differentiation of v, which in this case is 5. Can you divide the whole term by v square? In this case, your v square is 5x plus 2 square. V 5x plus 2, v square 5x plus 2 square. Okay? So from here, dy over dx, so is equals to, so let us perform the expansion. Okay, so 5x times it 4x, so from here get is 20x squared, so 5x times it 4. Okay, that is 20, so 2 times it 4, you get is 8. So from here, get is 28x. So 2 times it 4, you get is 8. Okay, basically I just skip one step, guys. Okay, 5x times it 4, you get is 20x. 2 times it 4 is 8x. So 20x plus with 8x, so that's how you get this 28x. Okay, minus with, okay, let us perform this expansion. So from here get is 10x squared minus, plus 20x plus 40, and then you divide with 5x plus 2 square. Okay, so let us solve them one by one. So from here, 20x squared minus 10x squared, so from here get is 10x squared. 28x minus 20x, so from here get is positive 8x. Negative 8 minus 40, so from here get is negative 32. Okay, and then you divide with 5x plus 2 squared. Okay, let me just double check again. Okay, all right, perfect. So this is your final answer for example 3. So let me underline the solution. Okay, so we have come to the end of the lecture video for today. So in this lecture video, we have literally discussed the products rule and the quotient rule, and I hope you have understand all of them. Plus we have discussed together with the example as well. So I hope you understand them as well too. Okay, if you like this video, make sure that you give a thumbs up. If you haven't subscribed to the channel, make sure that you subscribe to the channel and hit the bell icon for more upcoming AdMaths lecture videos in the future, and make sure that you share this video with your friends. Okay, so thank you everyone for your support, and I'll see you in the next video.